So now that we've spent some time talking about radian measures, and we've talked a little bit about, or reviewed a little bit with your SOHCAHTOA trigonometry, we've done a little bit more with law of sines, law of cosines. We're kind of going to bring that all together into talking about how trig functions relate to angle measures within the coordinate plane, and how we can use those relationships to find certain trigonometric values. So we're going to start off by just what we call extending the trig ratios. So you already know what the trig ratios are. We are going to look on the x and y axis, the coordinate axis. We are going to put one side of the triangle on the positive x-axis, and then we rotate, like we were doing when we started our radian and angle measures. And we're going to rotate counterclockwise and then form a triangle that has that angle measure. Now, particularly here, we're going to see that a point that's on that ray, at that terminal side, a point that's on there, we can find, or we can define that point as having coordinates x and y, right? And in particular, if we kind of draw in this right triangle here, we can see exactly that x is actually the adjacent side to this angle measure, and y is the opposite side to the angle measure. And that leaves us with the hypotenuse being what we call r. Okay, now how do you find the length of the hypotenuse r? Well, since we have a right triangle, we can just use the Pythagorean theorem. Right, so x squared plus y squared equals r squared. Now, if you're just trying to solve for r, we just have to take the square root of both sides. So we have r is equal to the square root of x squared plus y squared. Okay, so now let's try to write out all of our trig ratios in terms of x, y, and r, now that we know how to find r. So, starting off with sine of theta, so we're using our regular SOHCAHTOA because we're working with the right triangle here. So sine of theta is equal to opposite of our hypotenuse, which is, in this case, y over r. Cosine theta is equal to the adjacent over the hypotenuse, which is x over r. And in the same way, we can find all of the trig ratios. We just found sine and cosine. We can find tangent this way, and we can find the reciprocal trig ratios as well, just by flipping all the fractions. So let's go ahead and write those all down. So sine theta equals y over r, cosine theta is x over r, tangent theta is equal to y over x, and then for cosecant, secant, and cotangent, we just flip each of those ratios over. So we have r over y, r over x, and x over y. Okay, we also have this picture over here on the right, just so you can see that it doesn't just apply to if you're working with a triangle that's in the first quadrant there. It actually works for any angle measure, even if it's past 90 degrees. So we start with the right triangle because it's easier for us to grasp, it's easier for us to get those ratios from there, but we can actually use these ratios no matter which quadrant we're in. In case you're wondering, this does lead us to have some negative, possibly negative ratio measures, which normally with a right triangle you would never have that because all of the side measures are positive. But because we are working in the xy coordinate plane, now we'll have, it's possible for us to have x and y values that are negative depending on which quadrant you're in. So take a look at this first example. Find the sine, cosine, and tangent of the angle theta, whose terminal side passes through the point -3, -2. Okay, so we can use those formulas that we just came up with. We know what x and y are, right? That's given to us. X is -3 and y is -2. And then we just need to figure out what r is equal to. Now we said r is equal to the square root of x squared plus y squared, and that came from the Pythagorean theorem. So we'll go ahead and do that. That comes out to the square root of 13. I would suggest keeping this in radical form. If it is a perfect square and you can take the square root of it, then please do. But in case it isn't, in this case 13, just leave it as square root of 13. All right, so you're trying to find sine, cosine, and tangent. So sine, remember, is equal to y over r. So that's negative 2 over the square root of 13. If you rationalize that denominator, then all we have to do is multiply by root 13 over root 13. So we end up with negative 2 root 13 over 13. All right, next is cosine. Cosine is equal to x over r. So that would be negative 3 over root 13. Again, rationalize the denominator. We end up with negative 3 root 13 over 13. And lastly, we have tangent of theta, which is y over x. So that's negative 2 over negative 3. And the negatives cancel, so we're left with 2 over 3. All right, so now you know how to find the trig ratios if you know where the terminal side, a point going through the terminal side, what that point is. You can find r. After you find r, it's just y over r for sine, x over r for cosine, and y over x for tangent. Now, in particular, we're going to also be working with the unit circle. And so when we are working with the unit circle, those trig ratios that we just went over are going to be exactly the same, except that the radius is actually already given to you. So when we're working with the unit circle, we know that the radius is equal to 1. So that's actually a little bit easier, because now you don't have to solve for r. So really what you end up with is sine is y over 1, which is just y. Cosine is x over 1, which is just x. Tangent's still going to be the same, so y over x. And then for cosecant, secant, and cotangent, we just have to find the reciprocals of each of these, so 1 over y, 1 over x, and x over y. Now, again, remember, this only applies when you know you have the unit circle. If you aren't told that you're working with the unit circle, you're going to need to solve for r, and then use that value when you're finding the trig ratios. Okay. Now we can use the same chart that you had to memorize a little while back, but instead of using degrees, if you remember, we were working with the special right triangles, so we're working 30 degrees, 45 degrees, 60 degrees, but instead of that, we are actually going to use radians, now that we have been starting to work with radians, and you'll actually hopefully find that using radians will end up actually being a lot easier than using degrees once you get used to it. Okay, so just to write this chart down for yourself, just to remind yourself, remember this is going across. They're all over 2 for sine and for cosine, and it goes 1, root 2, root 3. Cosine goes the opposite, root 3, root 2, 1. And then tangent is root 3 over 3, 1, and root 3. All right, so now let's find the exact values of sine, cosine, and tangent when we're looking at an angle measure of 0, pi over 2, pi, 3 pi over 2, and 2 pi. These in particular will come in, will be easy to find using what we just wrote down for the unit circle, what sine, cosine, and tangent are on the unit circle. So let's just take a look. So t equals 0, that's the one on the positive x-axis. When it's equal to pi over 2, that's on the positive y-axis. Pi, which is at negative 1, 0. 3 pi over 2, which is at 0, negative 1. And then 2 pi, which is actually the same as at 0. Okay, so we are going to fill in this chart. Let's write down for ourselves what we just wrote down for the unit circle, right? So sine of t is equal to y. cosine of t is equal to x, and then tangent of t is equal to y over x. Okay, so sine of t is equal to y. So if t is equal to 0, so let's start here. When t is equal to 0, we're looking at this point right here. Okay, so at this point here, what is, well, if I'm trying to find sine of t, that's equal to y. What is the y coordinate here? The y coordinate here is 0. So sine of 0 is equal to 0. Cosine of t is equal to x. So you ask yourself, what's the x coordinate here? The x coordinate here is 1. So cosine of 0 is equal to 1. And then tangent of t is equal to y over x. So you do y divided by x, in this case 0, divided by 1, and that is equal to 0. Okay, so really you're just looking at the x and y coordinates at each of these points. So let's keep going. So at pi over 2, we're looking up here at the top of the unit circle. Sine of t is equal to y, so the y coordinate is 1. The x coordinate here is 0, so cosine of pi over 2 is 0. And then tangent is y over x, so that's 1 divided by 0. So that's going to be undefined. Okay, on to pi. So for pi, we're looking here at -1, 0. Your y coordinate is going to give you sine, so that's 0. Cosine of pi is equal to the x coordinate here, that's -1. And then tangent is y divided by x, so that's 0 divided by -1, so that's 0. All right, moving down to the bottom of the unit circle at 3 pi over 2. Okay, so here our y coordinate is -1, so sine of 3 pi over 2 is -1. Cosine of 3 pi over 2 is equal to the x coordinate, so that's equal to 0. And then tangent is y over x, so that's -1 divided by 0, so that is undefined. All right, and then 2 pi, well, this is actually just the same as at 1, 0, because we're back where we started, so this is going to be the same as the values for when t equals 0, so that would be 0, 1, 0. Okay, so the next thing we're going to go over are what we call reference angles, and reference angles will be, as their name suggests, a way for us to reference what the value of the trig ratio will be for a specific angle measure. And reference angles will actually make it much easier to determine what those values are. But before we actually go into it, we have to define what is a reference angle. Okay, so for an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Okay, so you take the terminal side of your angle and you find the closest x-axis. Wherever that is, either the positive x-axis or the negative x-axis, whichever one is closer, the angle measure that's formed there is what we call the reference angle. It's an acute angle, and it's always going to be positive, so we're never going to deal with negative angle measures here. Okay, so here are the 4 different cases. Here's the first one. So this t with the little apostrophe, we're going to call that t prime. That's going to be the reference angle. T is going to be the original angle measure that's given. So in this particular case, when you're in quadrant 1, when the terminal side is in quadrant 1, the reference angle is going to be exactly the same as the angle measure. Okay, in the second case, if you're in quadrant 2, so notice in blue there, that's your original angle measure t that's given to you. And then t prime, the reference angle, you just take that terminal side and find the closest x-axis, which in this case is the negative x-axis. And that angle measurement is going to be T prime. That's going to be your reference angle. Now, the way you can easily find what that measure is you really just have to ask yourself, if you're thinking in degrees still, you're thinking, what do I have to add up to? What do I need to add up to 180 degrees? In this case, we're trying to move away from degrees and trying to move into radians. So you want to ask yourself, what do I have to make T prime in order for T and T prime to equal pi? Right, so T prime is just pi minus whatever angle T is. Okay, the third case, if we're in the third quadrant, again, you see in blue there, that is T, the original angle that's given to you. And the reference angle is T prime. Again, you take the terminal side, the closest x-axis, which in this case is the negative x-axis, and that is your angle measure, T prime, your reference angle. So in order to figure out what that is, we take whatever T is, the original angle measure, subtract off pi, and whatever is left is your reference angle. Okay, and then the last case is in the fourth quadrant. And in this particular case, the terminal side to the nearest x-axis, in this case, would be the positive x-axis. And to figure out what T prime is, you would take 2 pi, which would be the entire thing all the way rotated around, right? It's 2 pi. If you subtract off T, whatever's left over is going to be your reference angle, T prime. Okay, so the next two examples that we're going to go over is just going to be a way for us to practice what those reference angles are, and then next time we are going to actually use those reference angles to help us find trig values. So let's start off with example 2. We're going to work with degrees first because I know you're probably still a little bit more used to working in degrees. So here it says, find the reference angle for t equals 240 degrees. Okay, so 240 degrees, you want to think about how far this rotation is. So we know 180 degrees will take us to the negative x-axis. We know it's more than that. How much more than that is it? Well, is it 90 degrees more? Well, 90 degrees more would take us to 270 degrees. So the important thing here is when you draw it, you want to make sure you're in the correct quadrant. You don't have to be very precise with exactly how you draw it within that quadrant, but you need to be in the correct quadrant. Okay, so here's our initial side. We rotate 240 degrees. Now we need to know what the reference angle is here. So the reference angle, we're in the third quadrant, so we're in that third case. We need to figure out what the angle measure is from this terminal side to the nearest x-axis, which in this case is the negative x-axis. So this angle measure here is what we're trying to find. Okay, so you have to ask yourself, well, if this entire thing here is 240 degrees, how can I figure out what this angle measure is here? Well, we know that the rest of it is 180 degrees, so if we do 240 minus the 180 degrees, then we can figure out that this is going to be 60 degrees. Okay, so now let's do an example that uses radians. So we have t is equal to 3 pi over 4. Find the reference angle. So now we have to, again, think about which quadrant you're going to be in. So I always say, if you're not used to using radians, just remember that 2 pi is a full rotation, which means pi is half of a rotation. Try to think of the angle measure in radians in terms of pi and 2 pi. So in this case, we have 3/4 of pi. So that's not quite pi. So that's not quite half a rotation. Is it half of half a rotation? So is it 1/4 of a rotation? No. 1/4 rotation would be pi over 2. right? So if half a rotation is pi, then pi over 2 is half a rotation, then 3 pi over 4, 3/4 of the way to pi would put us in the second quadrant. Okay, this will take a little bit of time to think about, to start thinking of things in radians, but try to remember pi is half a rotation, 2 pi is a full rotation. Think of the angle measure given to you as a fractional part of pi, so in this case 3/4 of pi, so 3/4 of half a rotation. Okay, that puts us in the second quadrant, so this is 3 pi over 4. Now you're trying to find the reference angle, so you take the terminal side and find the nearest x-axis, which in this case is the negative x-axis, and we are trying to find what this angle measure here is. So ask yourself, what do I have to add to 3 pi over 4 in order for this for both angles to equal pi? So we have 3/4 of pi. If we add another quarter of pi, we'll end up with pi, right? 3/4 plus 1/4 is equal to 1, so you'd end up with 1 pi. So this reference angle here is pi over 4. Now, one of the tricks with reference angles, particularly when it comes to reference angles in radians, is that your reference angle will always have the same denominator as the original angle that's given to you. So for example, in this case, 3 pi over 4, it was over 4, so I know that the reference angle will also be over 4. So that's kind of a nice trick that always is going to work when you're working with reference angles. Okay, so next time we will be working with reference angles and using those to actually find trig values.